All right, welcome back, everybody. I'm very sorry I forgot to start the video, but I just want to do the video going over the review for the test. I'm just going to go question by question so that you guys can see exactly how to do things. I mentioned this to my class in here, but if you see it on the review, it will most likely be on the test. If you don't see it on the review, it will most likely not be on the test. So just know in terms of difficulty and in terms of types of problems, you'll see pretty similar stuff from this review to the actual test. All right, so we decided to go with equations 1 and equation before you tuned in. We decided to go with equations 1 and equation 2 and multiply equation 2 by -1. So that's what you see here. Regular old equation 1 and then multiply -1 times equation 2, which gets us a -4x, a positive y, a -2z, and a positive 3. Now I add down and I get a -3x. The y's cancel out, the y's eliminate. Negative z is equal to positive 1. All right, so now I guess we can choose here. We want to do something with equation 3, right? We need to multiply equations 1 or equation 2 and then eliminate with equation 3. I know I'm not going to multiply equation 3, so let's keep that down on the bottom there. Let's say 2x minus 3y plus 2z is equal to -7. I guess, what do we want to do? Do we want to eliminate with equation 1 or equation 2? 2? Sure. Okay, because it doesn't really matter. It doesn't really matter because look at my coefficients on y. They're both -1. So 6 of one, half dozen of the other. So we said equation 2, right, Anna Grace? Okay, so -1 times equation, oh, not -1. We want to multiply by -3. -3, oops, gotta be red. -3 times equation 2 to make my y values cancel out, which means I will have -12x plus 3y -6z is equal to +9. And now we add down. We have a -10x. We have a -4z. -4z. And a +2. Okay. Everybody follow me there? So now I have a system of two equations. I've got -3x minus z is equal to 1. I've got -10x minus 4z is equal to 2. Now, let's multiply equation 1 by -4. Right, that will get me a +12x, a +4z is equal to -4. And regular old equation 2 here, -10x minus 4z is equal to +2. And now I add down. I got a 2x is equal to -2. So x is -1. Did we all get x is -1? Hopefully. Cross your fingers. All right, now let's plug it in to find z. Let's go back into our original top equation, or sorry, just this new system top equation. -3x, we know x. -3 times -1 minus z is equal to 1. So I have 3 minus z is equal to 1. So we have -z is equal to -2. So z is 2. And now we plug them all back in. Let's go. We got -1 and 2. All right, we got -1 something and 2. Wasn't -2, was it? No, it was +2. Okay. And let's go back into, I don't know, let's go back into equation 1. So -x, so -1, sorry, plugging in -1, correct? Minus y plus 2 is equal to -2. All right, so that gives us a 1 minus y is equal to -2. Subtract the -1, or subtract the 1, -y is equal to -3. So y is 3. Here we go. I'll tell you this right now, if you're getting decimals tomorrow, you know the drill. I wouldn't usually give you decimals, so. On tomorrow's test. Now, don't let that stop you. Don't let that trip you up. There have been cases in the past where students will have worked on this problem like for 35 minutes because they just keep getting a decimal, keep getting a decimal, keep getting a decimal. And then you know what? They don't finish the rest of the test. I have to take the rest of the test. Don't get hung up. Do the rest of the test. Okay? I kind of explained already how this is going to run, right? I'm going to be giving you the calculator portion. When I say calculator, I mean graphing calculator. I'll give you the graphing calculator portion. I think it's a white sheet. Then when you, well, one of them is yellow, or one, I can't even remember now. When you feel comfortable enough to put your graphing calculator away, you will pick up the other version, put your graphing calculator away, pick up a red calculator, or again, you can bring your own if you'd like to. So if you have both copies out on your desk, your graphing calculator should not be out any longer. You can keep both copies. So you can still work on the graphing calculator section, but you just have to be comfortable enough with putting your graphing calculator away. Okay. All right. Questions about it? We good on this one? Okay, let's keep it going then. Number 2 here. The following table shows estimated college costs in 2004 for private school, in-state, and out-of-state. Costs are expected to increase 5%. Now, how do we increase 5%? What are we going to multiply by to make it a 5% increase? Am I going to multiply by 0.05? No. What am I going to multiply? Alex, tell me. 1.05. Yes. We're going to take 1.05 times my matrix. Now, what is my matrix here? My matrix is just a 1 by 3, right? Just a simple old 1 by 3. Oh, commas in between. And then 12, 841, and then 19, 188. Okay. I'm assuming I cannot use my graphing calculator on this, so I'm not going to scale and multiply with my graphing calculator. I'm just going to multiply in. It does say to label our final matrix, and I'll show you what that means in a second. But let's just take 1.05 times 27,677. 1.05 times 12,841. And 1.05 times 19,188. Okay, so those are my values here. That means my final matrix is going to be this 1 by 3, $29,060.85. Oh, geez, I'm not going to have room. There we go. And then we've got 483. Let's leave a 4 in there. 483.05. And then we've got 20,140. Oh my gosh. I can't write today. 20,147.40. Now it says to label our final matrix, so I'm just going to put the labels back on from the table. So this is private school, in-state, private, in-state, out-of-state, and then costs. Okay, just so we can interpret our results based on our scale of multiplication. Questions? We good there? Okay. Let's keep it going here. Find the matrix product. Show work, if it is defined. And then we'll define entry P32. Now, when I say P32, that must mean that I'm saying the product is equal to F times D. Like P is equal to F times D, right? All right, so now let's find F times D. We've got F is 4, 0, 1, 0, 2, 1, negative 1, 1, 3. All right, and then I'm going to multiply it by D. Negative 1, 2, 0, negative 2, negative 3, 1. Again, I do not have my graphing calculator for this portion, so therefore I cannot go through and plug it into my calculator and just, use my calculator. I gotta run the numbers. All right, so we have row. Actually, I should do this. This is a 3 by 3. This is a 3 by 2. So what's my solution going to be? 3 by 2, right? So that's going to be one of these here. And now we multiply row and column together. So this is going to be row 1, column 1. Okay. Row 1, column 1. Okay, we got negative 4, 0, negative 3, negative 7. Well, that's Right? -4 and a -3 make -7. We do row 1, column 2. So 8, 0, and 1 make 9. We have row 2, column 1. So we've got 0, 0, and -3, so -3. We've got row 2, column 2, 0, -4, and 1, so -3. We take row 3, column 1. We've got +1, 0, and -9, so -8. And then we take, okay, we got -2, -2, so we're at -4 so far, and then 3, so -1 altogether. And that's my answer. Yes?
Should we write out like that?
Write out more than just this?
Right, just the answer. Should we put this and this sequences or just?
I say show work. Honestly, I used to say show work because we used to have like this all graphing calculator. I guess if you're doing it without your calculator, then I'm okay with just the answer. Yeah. Okay, what is entry P32? Remember, what does that mean? That means this is location, row 3, column 2. P32 is -1. Should be a lowercase p, but I won't be exactly. Questions about that? Okay, let's keep it rolling then. C minus 3a. Okay, so this is a lot easier than taking matrix multiplication. This is subtraction with some scalar multiplication. So C is 1, -1, 3, 2, 5, -1. And then minus 3 times matrix A. So 9, 12, 3, -6, 0, -3. Everybody follow me what I did there? I just took 3 times matrix A. I just went in and multiplied every entry times 3. 9, 12, 3, -6, 0, -3. And now just be careful, I have to subtract them. So therefore I take 1 minus 9, -8. I take -1 minus 12, -13. I take 3 minus 3, I get 0. Watch out here, 2 minus -6, that turns into an 8. 5 minus 0, -1 minus -3, so -1 plus 3 would be +2. Check your answers there, folks. Questions on that one? Yes?
Would ever be where that was saying C times -3 times, like it would be, because it was underneath, like the problem right above it where it said find the product. So like there was.
Oh, so you were thinking that it was like more product stuff. Yeah, no, I probably wouldn't do that to you. That's kind of weird. I would have to be very particular about the notation. Like I would have to do, because commutative property doesn't hold, so I would almost have to do like this. You know what I mean? I would have to like show that within parentheses which ones I want you to group first. All right, questions on that one? Good there? Okay, let's keep it moving. Use the matrices named below for problems 9 through 12 to tell whatever that doesn't mean that. Okay, sorry. So probably just 5 and 6. Can I do PQ? Can I multiply PQ? Yeah. I've got a 5 by 2 times a 2 by 5. So the result is a 5 by 5. Good thing that we're not making us do that. 5 by 5. 25 entries? Yeah. And then QR, 2 by 5 times a 1 by 5. Can I do that? Nope. And again, we're looking at these match. That's why I can multiply. These do not match. That's why I cannot multiply. Questions on that? Let's keep it going. Use the matrices below, blah, blah, blah. 7. I want to do F times H. F times H. All right, so F times H. I've got F is a 1 by 3, and then H is a 3 by 2. 3 rows, 2 columns. So what's my solution matrix going to be? What's my solution going to be? I've got a 1 row, 3 column, and a 3 row, 2 column. So what's the dimension to be? 1 by 2? Yeah. 1 row, 2 columns. Okay, that's not too bad, right? 1 row, 2 columns, just 2 entries. All right. So now we take row 1, column 1. Be careful here. I'm going to go in my calculator and I'm actually going to plug this all in. So we got a negative 0.5 plus, and then 2 times 0.75 plus, and then negative 1 times 0. Okay, so yeah. So we get a 1. I'm going to write in a highlighter. 1. And then we take row 1, column 2. So we get 4 times a half. So we got 2, 0, and then a positive 1. I think that would be a 3. Okay. We good? Okay. All right, here we go. Questions about that? Sorry, I'm weird. Find the determinant. Find the determinant. Remember that you have to be able to solve for a determinant without a graphing calculator. Remember, to find the determinant, you find the difference in these and then minus that, right? So we have it's equal to 9 minus a negative 1. So my determinant is 10. Questions about that? Now, there will be someone tomorrow that does not use Kramer's rule, and you will be very sad because you will not get credit for that. Okay? So please do Kramer's rule, please. What's wrong with number 9 right off the bat? Right, not in standard form. So we take 2x plus 3y is equal to 5, and then we add the x over to the other side, so x plus y is equal to 1. Okay, now we're good. Let's find capital D. Let's find big D. That is the determinant of the coefficient matrix, 2, 1, 3, 1. Okay, so that's a 2 minus 3. So negative 1 is my D. Okay, so now my x term. So now the fact that I get a value, a number, means that this is not a special case. This is not a no solutions are all real numbers type deal. Okay, so it's divided by, each thing is divided by negative 1. So now what do we do in the numerator? Well, we replace the x coefficients with our constants, so 5 and 1. 5, 1, 3, 1. All right, so we got 5 and 1 for my x coefficients. My y values remain the same. So we got 5 minus 3 all over negative 1, so 2 over negative 1, so negative 2. And then for the y value, again, we replace 5, 1 with my y coefficients. So my x's stay the same, 2, 1, all over negative 1. So that's a 2 minus 5 over negative 1, so negative 3 over negative 1. So positive 3, negative 2, comma, positive 3. Questions about that? You must show all of that work. Yes?
Is that supposed to be 3y in the first one?
Okay. Beep, beep, beep. That makes sense. We're good? Okay. All right, so now we can use our graphing calculators. Now life gets a little easier. I don't know whether you know how to use your calculator or not. Maybe it's not so easy. I want to find the inverse of this matrix. Now, when I go to find the inverse, I go back into matrix and I scroll right twice to edit. And now I click in there and I want to find the inverse of a 3 by 3. So I go in 2, 1, negative 1, 0, negative 1, 3, negative 1, 0, 2. Okay, just double check. You'd hate to miss points just because you plugged it in wrong. I'll go top to bottom now. 2, 0, negative 1, 1, negative 1, 0, negative 1, 3, 2. Okay, we're in correctly. I go back out to my home screen. Remember, whenever you want to do an operation, you go back out to your home screen. You say matrix A inverse. Ooh, that's weird. Looks like I should probably put this in fraction form. Remember, to do that, you just hit math, frac, enter. Okay, yeah. Now for my screen, it looks a little weird. I actually have to scroll right to make sure that's the end of the matrix, and it is. So there is really my solution there. It should look like this. 1/3, 1/3, negative 1/3, 1/2, negative 1/2. Oh, that's just a 1. That's why. A 1, a 1/6, 1/6, 1/3. There we go. Okay. Yes.
Will we get more stuff if we don't put in fractional form?
You know, if it tells you to put it in a fraction form, do that. If not, then I wouldn't care. Just know that you can do that answer to fraction. Thank you. All right, now when it says to write the matrix equation, okay, write the matrix equation. What I mean by that, well, again, first thing I have to do is put this into standard form, right? This is actually both equations are not in standard form. The top one needs to be turned into negative 2x plus y is equal to negative 1.5. The bottom one, add the x over to, oh, sorry, not add it, just move it, right? Negative x plus y is equal to 0.5. Right? Make sure the x's, the y's, constants are all lined up. See, that second equation is a little deceiving because it goes y, then x. It's got to go x, then y. All right, so now here is my matrix equation, right? My matrix equation is the coefficient matrix, negative 2, negative 1, 1, 1, times your variable matrix, in this case it's just xy, is equal to our constant matrix, negative 1.5, 0.5. That's what I want to see when I ask you for the matrix equation. I want to see it all written out. Okay, now we go to our calculators and we go into matrix. We scroll right twice to edit. And now I put in my coefficient matrix, which is a 2 by 2. Negative 2, 1, negative 1, 1. And I go back to edit B, which is going to be negative, still a 2 by 1, negative 1.5, and then a 0.5. All right, and now remember what we do here to solve this. This is A times X is equal to B, right? So to solve this, we would write X is equal to A inverse times B. A inverse times B. So that's what we do in our calculators. Matrix A inverse times matrix B. Okay, there it is. So my answer is XY is 2.5. Right? Remember that, don't lose sight of the end goal. I'm solving the system, which means I want the location. I want a 2, 2.5 on the answer book. That's my answer. I solved it by way of matrix equations, but I want that answer. Questions on that? Last problem, here we go. The cost of 2.5 pounds of figs and 1.5 pounds of dates is $14.42. The cost of 3 pounds of figs and 1 pound of dates is $16.91. Use a matrix operation to find the price per pound. Okay. Well, this piece in here, it's like throw back to chapter 3, right? I give you information, you give me back a system. Okay, 2.5 pounds. Let's say X is figs, Y is dates. It's always really important. Make sure that you define what X and Y are. All right, 2.5X plus 1.5Y is equal to 1442. 3.5X plus Y is equal to 1691. 1Y or just Y. All right, matrix operations would just be matrix equations. So here's what I'm going to write. 2.5, 3.5, 1.5, 1 times XY is equal to 1442, 1691. Now I go into my calculator. Matrix A is going to be still a 2 by 2, but in this case it's 2.5, 1.5, 3.5, 1. Go back into matrix B. And now this is 1442, 1691. Whoa. Whoa. Whoa, whoa, whoa. 2 by 1. No, not 11. 2 by 1. There we go. 14, 42, 1691. Whoa. Whoa. That was weird. Okay, now I'm going to go back in and I want to do the same operation. So shortcut. Second entry brings back the last thing that you did. Okay, so there we go. 3.98, 2.98. Okay, so that means X is 3.98. So we would say $3.98 per pound for the figs and $2.98 per pound for dates. That's truly my answer. Remember, don't give me this. Don't give me a matrix as your answer. That has no context. Everybody get 100% on that? Let's go. No, it's not time. It's not time for baseball. All right, any other questions for the good of the order while it's still recording? Other than, is it time for baseball? No? Everybody watching along at home, make sure you're checking your email. I'm going to send you guys an email about how to take the test if you want to take it before you get back. Okay. All right, I'll see you, everybody. So long. Farewell. I'll be the same. Goodbye.